So, good morning, everybody. My name is Turk, and I hope you all liked the keynote this morning. Everybody awake here now? Nice, nice. So we can rock again here. Yeah, I'm coming from the Netherlands, and in the Netherlands we have tulips, we have cheese, wooden shoes, and we also got stroopwafels. So if you want a stroopwafel at the end of the session, just grab it. I have more, so you're more than welcome. And we also have windmills. And I love the idea of a windmill because it's using its energy for something else. For example, in our neighborhood we have one that is graining the wheat into flour. And they use it in the bakery and that kind of things. You also have wind turbines, of course, but that's, yeah, you don't want to have that in your backyard, but somewhere else. I think the idea is good, only somewhere else, I think. So we are going to talk about NASA and what we can learn from it, in also with sustainability. And with sustainability, we mostly talk about CO2 and about energy. The energy we are getting mostly from the factory, for where we have coal or also solar panel or that kind of things. But today we are going to talk about reducing energy from the factories, so that we can improve there. And of course, also you see CO2 is coming from everywhere, so it's not an easy solution everywhere. But what is CO2? It's a molecule. It has two molecules with two O's and one C. It's carbon dioxide. And what it is, CO2 is like if we have a lot of CO2, then it can feel like a big blanket above our head. So not a lot CO2 is also not good, because then it's getting colder. So that's also not good. So we need to find a balance here, and probably now we have it way too hot, I think. But we improve there, I think, also. But we can improve as a world even more. Yeah. But CO2 is not only in the air or in the water, it's also in our food. So every day when you're eating, going to the bakery and ate a sandwich, for rising, they're using also CO2, so putting CO2 in it. And yeah, I like also Coke, and in Coke is also a little bit CO2. But that's all good. I think we can solve the problem by drinking a lot of Coke and eating a lot. No, just kidding, of course. But yeah, you can. Yeah, we need to improve, right? And if you have CO2 and H2O, so if we have a lot of rain and with a lot of CO2, the rain is coming down and it's coming into our water, and then you can get a kind of acid, carbonate acid. And that's really not good for our sea life, because yeah, we have corals and they will die, and the temperature will also raise, of course, because the CO2 is in air, it's getting warmer, and then yeah, it will be going bad. And now I'm going to talk about also with NASA, with data open APIs. So that's a little bit mixed feelings here. But actually, we can learn a lot from space technology. And I think there's also the solution. Because, yeah, it's getting a lot of CO2 there. So that's definitely not good. But we can learn from it. Because we have so much to get from space technology. We have, for example, the super soaker we have. We have the headsets, for example. We have the fire alarm. Yeah, there's just some jokes, of course, but actually we have also something really good, and those are solar panels. And solar panels absorb a lot of heat and creating energy of it. And actually that can also be a little safe, I think also, but there are more things we can benefit from the space technology. And that's why I combined space to code and using data APIs with Kepler. Yeah, my name is Turk. I'm coming from the Netherlands, what I said. Please connect me through LinkedIn. I'm a developer also, a JUG lead, conference speaker, and I love to talk about green software. And I'm working at Code Lab. And I'm also a conference organizer for Fox Days Amsterdam. So if you're in the neighborhood, love to see you there. And I'm actually also working in Utrecht, what I said. I'm working at a big bank. I don't say the name because it's not good if I say it in Portuguese. It's a big bank. And I actually work here, and it's really nice. We have a nice view, and yeah, it's great to work there. I want to ask you, could you please join the Slido here? That make me very happy. So if you are having questions, we will look at the end, and I will try to answer them. And yeah, it's also a little bit about expectation maybe, but just leave it now for questions. So if you have a question, leave it there, and I will answer them in the end. And if we have time, I will answer them. Otherwise, you're welcome to come here. Today we are learning something really useful in my opinion, because I'm very practical, I'm a developer, and I like things to use in my daily work. So how much of you are using Spring Boot? Can I have a raise of hands? Okay. Quarkers? A few, okay. So yeah, I'm going to create a Spring Boot application, sorry about that, but yeah, it's the more people are using Spring Boot, so that's why. We are going to call the NASA Data API. And we are going to call it, and we get some really nice pictures from it, and yeah, some data we can maybe use in our daily work. We are going to create a Docker image with JRelease. How many people of you know JRelease? Can I have a raise of hands? A few. Okay, this will be really a nice tip, I think. Who's using SDK, man? You have a raise of hands? So, okay, that will be maybe some interesting stuff also to use in your daily work. And we are also going to monitor its usage with Kepler. And Kepler is a tool that you can use to measure your application's carbon footprint. So this is pretty new, so I assume a lot of people don't know it yet. So we have a mission. I have a mission, and we are going through space, and we're going to several planets. We are going to the moon. We are going to Mars. We are going to the asteroid belt here. It's a Dutch guy, by the way, that saw it. And we have also an exoplanet, and that will be also pretty interesting, because last month they have some interesting news about life out of space or in space. Yeah, what I already told, we are looking into space, the moon, Mars, asteroids, and exoplanet, and we're using those NASA data APIs. But yeah, we need to start somewhere. And where do you start if you're talking about space? About the Big Bang. That's where it all started. Because in the past, in 1927, an astronomer, George Lemaitre, I need to say, and he had a big idea, and he said it a long time ago, that the universe began with the Big Bang, and it's stretching out, and it's still stretching out. And I'll tell you more about that later. And yeah, just 2 years later, Edwin Hubble, and he said like, hey, if you are farther away, it's moving harder than when you are at the close in the beginning. And yeah, our question today is there life on other planets? So a combination what we will learn with technique, of course. And just an interesting question. Who believes that there is life on other planets? Can I have a raise of hands? Who don't believe it? Oh, we are pretty scientific, so that's nice, I think. Or yeah, maybe it can combine, of course. So the question is, are we alone? I don't think so. I think, yeah, we are kind of unique, but not that unique, I think. So we are going to look into space. And how are we going to look into space? Who knows what this is? Almost. This is the James Webb Telescope. And it measures far away the stars, and it's searching for life at other planets, and also yeah, it's looking to stars and far into the space, right? And yeah, it's also looking to planet formation and exoplanets. And this is another one. It's called the Kepler. And there's a Kepler scope, and there's only one created from NASA. In 2009, it's created. It's already older than the James Webb. It's some older, but it's also checking if there are exoplanets in space. And how does it do it? It's doing with light flashes, infrared. And if it's too long, that is coming back, then you know, like, hey, probably there's something in between. And then you know, like, hey, maybe it's a planet, and they have all kind of techniques for it, and even with the atmosphere. And yeah, the first one was broken, but then they fixed it, and they use it with K. Yeah, they say like it's K2. And every time when they see a new star or a new planet with Kepler, then it's mostly beginning with K2. But yeah, who was Kepler? Johannes Kepler was an astronomer. He was also a writer on music and that kind of things. And he founded something pretty interesting. Like you have here our galaxy, the Milky Way galaxy, and in the beginning is the sun, of course, and then have your Mercury, Venus, and then have Earth, Mars, and further. Yeah, you can see that he just discovered that it's rounding, so it's like, hey, it's going round and round. So that's pretty interesting. So that was his law. That's what he's seeing. Like, hey. Yeah, there must be something that we can use also in space. And he also discovered that it's not moving only around, but it's also moving in a certain direction, round and round and round and round, like here. So we actually also moving on the other side, and we are stretching. So that's pretty cool because, yeah, with this model, he also said like, hey, it's moving, so this is the truth. Yeah, and we are going to a journey because we are going to other planets, and we are going into space, and we're going into space not with a rocket, but with NASA data APIs. And yeah, NASA have a lot of information you get. It's publicly available. Everybody can use it, and it's pretty interesting. Let's go. Am I there? Check. And they have a NASA data API website you can use. I'm going to wait. I'm going to mirror it, change, start mirroring, yeah, check. And yeah, what you need is an API key. You can just generate it, and then you're all set. And you can also browse all set of APIs. You can get the picture of the day, like everybody they're using the pictures of what they get, and they share it with other people. You have asteroid information, like, hey, what kind of asteroids we have, and are they harmful? Mars rover photos, also pretty interesting. I will show you later. And also some things about our own solar panel and also exoplanets, because there are a lot of exoplanets they already discovered, and you can also see it in a kind of database way, and I'll show you later. Let's change, check, extend, check. It's ready. So we are going to create an application. We are going to create a Spring Boot application that is calling the NASA data API. And now again, I need to switch. Sorry about that. So let's switch again. Change to extend display. So not extend, but mirror. Sorry. Mirror. Yeah. So we are going to create an application, and that application we called Kepler. And we call it Kepler, and we're using Java, of course. Who's using Java here, by the way? Can I have a raise of hands? Kotlin? A few more people like Java. Groovy? No? Oh, still nice. So yeah, we are going to use Maven. I don't have such an experience that I use Gradle a lot, but I'm going to use Maven here, and Java 24. So we're using 24, and then we do next, and the only thing that I want to have is the Spring Web, and we do create. So at the moment we have, just delete the test. Don't need testing, right? Especially out of space, not right now. So what we are going to do is we are going to create an application where we are calling the NASA Data API to get the picture of the day. Just keep it first simple, and we are going to call it Astronomy Controller. And that controller has some things like for Spring we need of course a REST controller. I'm mostly doing a request mapping, and we call it just like space. We now created a controller, and we also need to create a get mapping, right? So at request mapping request mapping, thank you, Copilot. Public, Astronomy, and yeah, let's do it like this. It's just a get, a simple get, and we are going to use templates. So you can use a REST template. So I'm to call REST, you need a REST template. So I'm creating here a REST template. And let's import it, all the kind of stuff you needed, the bean, yeah, import it. And then we have a controller. It's, by the way, not in the space. So let's move it. Oh, I did the wrong one. And we have the space, so let's refactor, yeah. So the first thing we need to have is a URL. So, and the URL has a token. Now I already generated the token, and I'm going to expose it. I hope Copilot will help me also there. don't expose it. So I'm overriding it. Okay, I'm already exposing. But it's not a problem. We can. It's just publicly available. Yeah. What do we need? We need a REST template, right? So we need a private REST template. REST template. REST template. And we need a token, but the token is a value, so we need something like a value. Add value. NASA. Yeah, now I already exposed it, so close it. So we have an API key, and we're getting the token, and we need something like an object builder, right? Let's call it. We're just going here, space, an object mapper. I mean, so we have an object mapper. And with that object mapper, we also need to create a constructor, right? So we're going to create a constructor. So the URL. So what we're doing now is we're getting the object from the URL. So we're calling that URL and get a response back. But that response is a string. So we also need to read it. So we also need a response. I create a response here. New Java class, and I want to have it a record. I call it a name, astronomy response. And I have also a live template for this one. Then it's some saving. Oh, first. Response. So we have some JSON properties to get from the template, right? So missed this one. Yeah. Check. And we have the controller. So what's the read value? And we have a planet response. Yeah, just continue here. Planet response. So we're getting the response and returning an HTML. So HTML, sorry for the big font. Now it's returning. It's pressure this. What's here? Response, exception. It throws an exception, just add an exception. So at the moment we created a request mapping and we're going to start it. Let's see if the demo gods are with me. And we're going to read the application. It's already a controller being that could not be found. I've always a backup, so let's doing the backup here. And I forgot something. Yeah, that should be good now. Yeah, it's good now. So we created now a get mapping. So let's go to the get mapping. Where is it? Here. So at the moment we are calling the NASA data API, and every time I'm refreshing, it gives us new images and new insights from the outer space. And it's pretty nice because James Webb Telescope or Kepler or other ways are made this kind of photos from a far away galaxy. And that's pretty cool, I think, in my belief. So there's a lot of things you can measure. What is this? I think a kind of moon. Oh, it was there below. But there's all kind of things that could be interesting if you like space, I think. So that was the first API. I was at a session of Redis and Raphael, and he showed me something really interesting because the whole mission of the moon is actually on the internet. So we can just go to there and we can have a feeling like, hey, how was it back then? And if you are one of NASA, yeah, what's the story about?
Up to the ignition sequence at 8.9 seconds. We're approaching the 60-second mark.
CDR and LMP, panel 6 and 9.
T-minus 60 seconds and counting.
I'm going off.
T-minus 60.
And my bad guy, going off here. It's been a nice smooth countdown, Skip. Thank you, babe. LMP, VHS, increase it a little bit.
Real smooth countdown. We passed the 50-second mark. Power transfer is complete.
Copy.
We're on
They're running our power. Okay, is CDR TDC line.
It's mostly at 10 seconds, right?
Ignition sequence starts.
So this was the start of the Apollo 11, which bring the people like Neil Armstrong to the moon. So that was really a big thing because it never happened. Right, you see the whole story, like what happened. And if you can search famous so this was a big thing for humankind, I think. And it's pretty cool. And you can also search like big step.
Plus 30 seconds. Right, safety is normal. Roger, roll complete and the pitch is programming. Roger, roll, roger, pitch. Stand by for 1 Bravo.
All kind of things, like you can just search the whole thing, and then you can see like, hey, what they actually said there, and when they reached the moon at the end.
I guess there were none in our area. I took a stroll back.
So this was pretty interesting.
After putting up the PSAP and while Buzz was starting to unpack the documented sample, took a stroll back to a...
So actually here, when he was going down from the Apollo, he said some famous words, right?
It's 1 small step for man, 1 giant leap for mankind.
So mostly you see like all the pictures where he was just walking on the moon and then he had that sentence, right? But actually he was moving down when he said that, so I didn't know that. But that's actually, yeah, then you can also see them walking on the moon, and you can also going to the right, you can still see some interesting stuff, like hey, how it actually sees on the moon. Yeah, that's pretty cool in my belief. Again, check. So this is one of the missions of Apollo 11 indeed, when they're going back to Earth, and it was also pretty interesting because they are like going the circles again, like you also see in the solar system. They're making circles and then they get a push up to the Earth again, and then they're doing the same. So you again see the kind of circly thing. But yeah, we have one moon, but Mars, for example, has 2 moons. Jupiter had 67 moons, Saturn 64, Uranus 27, Neptune 14, and Pluto 5 moons. So we only have 1 moon, and that's pretty good. Otherwise, we couldn't exist because of the gravity and that kind of things. So yeah, there are a lot of planets and that kind of things there. And yeah, here you see already a lot of moons here, but yeah, that's what I said. Like, hey, a lot of planets. So let's go to Mars right now. Let's check. I want to have it changed to like extend. Check. So this is Mars. And Mars is the 4th planet from the Sun, and it's called also the red planet because of the iron oxide. And it has 2 small moons, what I said, Phobos and Deimos, which are not really round. And a day on Mars is like 24 hours, 24.6, and very close to an Earth day. And a year on Mars is like the double of us. But it gives some same things like the Earth. It's a little bit rocky, and they have a lot of, this is the Mars rover, and it's going around whole Mars and still doing that. They are still 2 active, but actually from 1997, there's already some man over some rover driving, and that's pretty cool. And the question is, are we going to Mars? That's the question. In the past, in 2013, people can really go to Mars and they can ask like, hey, I'll be a volunteer, one-way trip to Mars. That was possible in 2013. And 100 candidates come out of that because they have a lot of screening. It's a pity, but it lacked technical feasibility and financial backing up. So it was going bankrupt, and it was not good for space, in my opinion. But now we have another guy, I don't call names, but we have SpaceX, and they want to try again to land on Mars. And that's pretty cool, and that's pretty awesome, in my opinion. And we are going to call the NASA Mars Rover API. I'm going a little bit quicker through it, because I made it already. I created a Mars rover. I need to close this one, of course, otherwise I will get some exceptions. But we have also a response from Mars. So again, we're doing the same trick. We're calling a REST API, and we give it some values. Oh, yeah, thank you. Good point. Change, extend, mirror. Yeah, check. Thank you. So again, we have like a get mapping, and we're calling an API. So that's nothing new, and we marshalling it to a response and get the image source from it. So it's not so difficult. So I'm going to start again. Is this one? Yes. So actually, we now see some images from Mars. So we're now in a kind of connection with Mars via all kind of ways, of course, but this is pretty cool because now you can get, and you can actually also see the images from yesterday. So this kind of not live, but it's sending still images to Earth. And yeah, we now see, yeah, if they're live on Mars, then we should see this, but it isn't there. In the past, it was there because of maybe with water, they said, but yeah, it's a maybe. So we are now going to search from some asteroids. And as a kid, they said like, hey, when you are like around the 40, there's an asteroid coming and it will destroy our life. And now I'm almost like 40. I don't want to say it, but yeah, is there an asteroid coming? But apparently it isn't, so that's good for us. But we can also see some information from the belt. So there are two kinds of belts. So after Mars, we have a belt with asteroids here, and they already are going round. But we have a bigger belt after Uranus. That's calling a Kuiper belt, and yeah, they have a lot of asteroids, and we need to also watch them. Also comets that can come outside. So we need to monitor everything. And there's an API for that, an asteroids API. I will switch to asteroids. And again, we have a controller. We're calling an API, and we can search. For example, like the comet APOD. Yeah, so we are going to do this. And that's the next one. And here you can see like, hey, the comet. So here you have the image source, so you can search specifically to certain comets or that kind of things. And they said they will nearly miss it. So here you can see it, it's nearly missing it. So that's good for us. And these are, by the way, all kind of satellite. That's also not good, by the way, so much, but yeah, it's a bigger problem than that asteroid there, I think, but yeah, depends on how big it is, of course. And we have exoplanets. The question is there life? Let's travel 124 light years and check if we can find life. This is K2. It's seen by the Kepler telescope after it was destroyed and fixed again. And the 18th is the solar system, so you have a star. It's a dwarf star. It's a red, so it can be early to the sun. And it's saying like, hey, maybe it's rocky, we don't know yet. It's not up to date yet, but we can see a little bit how it looks like. And the color system, you can also check, like here you have the whole system. So it's like quite to the star, because it's dwarf star, and dwarf star is like, it's less hot, so it's better for the planet. So the habitable zone is more around the star. And here you can see like it's the red dwarf star. So it's giving some heat, so it's the sun is much heater. So yeah, is there life on other planet? Oh, I already have this one. So what I said, there's a dwarf star, and they said that it's like probably an ocean-like planet. So that's interesting, if they have oceans and that kind of things. And is it then the same like Earth? No, it's a kind of super Earth. So it's bigger. It's not so big as Jupiter, but it's smaller. But yeah, it's much bigger. And then the next question is, can we say that we found life then with this exoplanet? No. So they did a study. Cambridge did a study that they searching for kind of molecules, DMDS. And that's only produced by life. So what they did with the telescope, probably the James Webb, and they giving light flashes again, and then it's around certain time that it's like coming back. And that light is also going to the atmosphere. So they can see kind of that there is maybe life on other planet, on this planet. It's possible. Like it's the closest hit that we have so far. And this was just discovered 1 month ago. So this is pretty cool. So we found some life existence, maybe. It's never a 100% hit, because yeah, it's too far, we don't know. But they have a closer hit than all the others. And some information, like probably it's a water planet. They don't see like, hey, if there are land or something, but so there is water kind of things. And it has a red dwarf, what I said, yeah, and all kind of planets also. And it looks a little bit like Earth-like. So this is, yeah. So the habitable zone is like here. So we can also go on an exploration. So NASA has also a database with all things what they found. So for example, if, wait, let's do it like this, they can see like, hey, what's the gravity and how big is the planet. So we can search on K18b. It's probably K. K2. Okay, K2-18b. No. a capital B or something, or? Oh wait, I'm just checking it. Oh yeah, check. Thank you. I need glasses too. So here you can see actually where the exoplanet is on which star it is. Like it's in the solar system of K2-18. That's the star, and it's already confirmed, and all kind of ways that how they found it, and with all kinds of how big it is and how much days it has. Probably have 32 days in a year, and that kind of things are pretty interesting and gives us a glimpse of maybe life on other planets. But yeah, it's 124 light years, so we cannot go with that speed of sound, right? So we need to be careful on our planet, I think. Otherwise, we're becoming a kind of Mars, and that's actually a little bit happening. Like, hey, there are all kind of extreme heat already happening. And yeah, we need to be innovative. Like, hey, innovation is key. We need to have things like, hey, solar panels maybe that can help, but also in IT we can do something. We can monitor our own application. So let's measure our own application on energy consumption with Kepler. It's from Johannes Kepler. We have seen the telescope, and now we are going to monitor it with a Grafana dashboard, kind of, is it? Or it's an exporter, and you can use it with Grafana. And it's also handy because we need to comply on European regulations, because more than 250 people in a company, you need to comply it. It's a kind of financial report, and you need to show how sustainable you are. We are going to do this with Kepler, what I said. It's checking its data from the rappel. It's a kind of sensor and all kind of things on bare metal. So if you have a bare metal system, you can use like real-time metrics. And for a VM, if you're using a VM, they have a kind of model, and they're trying to be strict as possible. And the same for the other ways. So you have bare metal and VMS, and that's, yeah, it's different. And what can you see then? Yeah, you can visualize metrics. You can see how green your application is. It has some requirements. You need a kernel 4.18 cube, Kubernetes running, and a Docker or a Podman or Minikube, or whatever you want. And we can use it with SDK-man. And I already said it, like, SDK-man is really nice. Let's clear it. And SDK is, like, you can list Java versions. So at that moment, there are a lot of Java versions. Mostly I need to upgrade. I'm just using SDK. I'm using Tamarin. There are a lot of Java versions, and it's an OpenJDK, Liberica, Microsoft Oracle, Tamarin. I'm using now the 24 one. And I just can install it just right away from command line, so I don't need to go to a website, accept all kind of licenses. That's pretty nice. And I can just install it with a simple command, SDK install Java, and then the Java 24 something. You saw it. But that's pretty handy if you want to use another version of Java. But we can also use it with JRelease. And JRelease helps us to create a Docker image from our Java application, because we want to run our Java application on the Docker container, and that container we want to merge to the cloud. or we can deploy it to the cloud, right? So yeah, we created an application. It's called Kepler. Kepler. Where is it? Kepler. Yeah. So what we can do is you have a JRelease script, and you can use it. Yeah, where is it? JRelease, and it's using a YAML. So yeah, it has some things like a license, who's the author, website, and that kind of things. The artifact, but the most important thing, like things like, hey, I want to create the Docker image, right? And we're using a package, a Docker package with it, and it's creating a Docker image for us. And that's pretty interesting. And yeah, I also tried it for the first time a couple of months ago, and it's pretty nice to use. So what you can do is a Maven verify or a grade or something, and it's building. And then you say like JRelease, like assemble. Wait, not Docker. Verify. Okay, yeah, we can do the Maven verify, the JRelease assemble. Did I make a typo or something? I don't know. And we can do something like JRelease prepare. So the assemble is creating a zip, and the prepare is creating the Docker file. So I'm going back here, and oh, that's there. And we see that it's created a JRelease assemble and a zip, and that zip is used by the prepare, and the prepare you see like the Docker file. So here I have the Docker file. I'm using like the Zulu OpenJDK, all fine. You can change it, of course, and you can move this to your cloud and run the Docker together with your application that will be monitored. And that's pretty interesting too. And so you got a dashboard. I'm just going to my cloud environment, and that's a Grafana dashboard. Where's that's Grafana dashboard. And it's measuring all kind of things. So here you can measure your carbon emissions. So you can see like on certain times, it's making use of some electricity maps and that kind of things. It's make use of coal. So you can imagine in the Netherlands we have, in the afternoon, we have a lot of solar panels. So actually we're earning money by running our application or batch jobs in the afternoon, because we have then a lot of energy and you get also your energy back. If you run it in the night, you need to pay. And also the emissions are then also not so good, because we have then more coal we need for the CO2. So that's not pretty good for the CO2. So you can say to your company like, hey, we're using too much coal and we need to run more. If you have, for example, batch jobs, we need to run them on a certain time, and then we also earning money. Especially the last thing is very important, because managers want to hear that kind of things, and then you have a case. And also with petroleum and natural gas. So you can see what kind of emissions you have. And you can also see your power consumption, like the energy usage, what you did, for example, the Kepler. And you can see like, hey, on a certain time this morning, I did a lot, and at the end of the day, less. So you can see like, hey, I'm using my application around this time. Can we not move it to the afternoon? Because then we have, we are more sustainable. And then, that's pretty cool. So so the key takeaways are, and then we have some 5 minutes for the questions if you have. What you take home. Kepler tracks our carbon footprint. So that's pretty nice to have a kind of exporter for Prometheus. So we're saving our metrics from the system to a kind of database, Prometheus, and then we can read it from a Grafana tool or whatever. And then you can watch your actually CO2 emissions and also the energy. Yeah, we found out that we have JRelease and SDK man. Use it. That's pretty nice if you want to just install the latest version of Java. It's pretty quick. Nowadays you can also do it with IntelliJ or Eclipse. But yeah, with SDK man is just a command. JRelease it to release your artifacts to Docker, for example, and to production. And a NASA Open Data Viewers space inside. So that's pretty interesting to have a glimpse into our Earth or into our space, right? I also have some stickers here and also some stroopwafels. You want, just grab it. I have I'm coding green, Fuji, IO, because we need to share it, that we need to code more green. I try to have it sustainable, like but yeah, trying that. And Fuji is, by the way, for all your questions about this SDK. So if you have Java questions, you can go there. And of course, Java, right? Yeah, thank you for listening. Don't forget to get the sticker stroopwafels. And yeah, we have some time for questions. So let's wait. Let's do a few. Then the other one, check. If you have questions, it's also fine. If you don't have questions, I think we don't have questions. Does someone have questions here, or did I miss something, or no? Okay, then I wish you a pleasant day today and enjoy JNation, and thank you for coming, and please share the news about green coding. Thank you, and enjoy.